Okay, I just wanted to make another video going over some of the properties of the trig functions we've learned and expanding on them a little bit. I'm assuming at this point all of you have started memorizing the unit circle. I've said repeatedly in these videos that you have to have it memorized. So I'm going to assume that you have started to memorize those, and we're going to use one of them today to kind of build off of. So suppose we have a unit circle, theta equals 30 degrees. Again, by now you all know sine of 30 degrees equals 1/2, cosine of 30 degrees equals √3/2, and tan of 30 degrees equals √3/3. Those you have down, but now we want to kind of expand on that and use what's called reciprocal trig functions. And essentially we have three regular trig functions, sine, cosine, and tangent. And then we have three reciprocal trigonometric functions: cosecant, secant, and cotangent. And the idea is, you all know what reciprocal is. You've taken 171. A reciprocal is when you take something and flip it. The reciprocal of 2 is 1/2. The reciprocal of 5 is 1/5, and so on. For these trigonometric functions, the reciprocal trig functions, you just take a regular trig function and flip it, take its reciprocal. And the way it works is, sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, cotangent is adjacent over opposite. So essentially, it's like your SOHCAHTOA, but everything is turned around. And since we know sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, which means these two are reciprocals of one another. You can go back and forth. Take your sine, flip it, you get cosecant. Cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent, so those two are reciprocals. If you want to find the secant, take the cosine and flip it. Tangent and cotangent are obviously reciprocals. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. So for the purposes of this, suppose I want to find the reciprocal trig functions, the values for this theta, 30 degrees. Cosecant is the reciprocal of sine. Sine of 30 is 1/2. So cosecant is 2/1, 2. The secant of 30 degrees, cosine is √3/2, so secant is 2 all over √3, which we would then multiply by √3 on top and bottom and get 2 √3/3. Cotangent is reciprocal of tangent. Tangent is √3/3, so cotangent is 3 all over √3. Multiply by √3 on top and bottom, and you get 3 √3/3, which then just becomes √3. Essentially now, all this does is give us more trig functions to work with and mess around with. So in a lot of your homework now, we were just finding 3 trig functions. Now we're going to find all 6. So for any given angle, 30 degrees, 60 degrees, 100 degrees, instead of just finding sine, cosine, and tangent, you can find sine, cosine, tangent, secant, cosecant, and cotangent. And all you have to do is find the basic 3 that you already know using SOHCAHTOA, draw a triangle, however you want to do it, and then take the reciprocals and you get the 3 reciprocal trig functions. Okay, but we get other properties out of this too. Let's see, over here we have sine and cosine, here we have secant and cosecant, and then we have tangent and cotangent. And there's kind of this question, where do all these cos come from? Secant and cosecant, tangent and cotangent. What does the co mean? And it's actually referring to what's called cofunctions. And it's defined in your book, and the wording of it can be a little bit odd in English, but the idea makes a lot of sense. And essentially, 2 functions are cofunctions if you take 2 acute angles that add up to 90, so complementary angles, co-functions. Take two angles that are complementary, so they add up to 90. To use this as an example, we're using 30 degrees right here. So what's complementary to 30 degrees? 60 degrees. And two functions are co-functions if the two complementary angles that add up to 90 degrees give the same trig value for the two opposing functions. And again, the wording of it is a little bizarre, I know, but essentially sine and cosine, that's where the co comes from because they're co-functions, are co-functions. What is cosine of 60 degrees? Well, just using the unit circle, if you don't have it memorized yet, there's 60 degrees right here, and we know from right here, let's see, it is root 3 over 2, 1/2, sine is the y value 1/2. For 60 degrees, we get 1/2, root 3 over 2. And now for 60 degrees, what's cosine of 60 degrees? Cosine is the x value, which is 1/2. And now we see that sine of 30 degrees is equal to cosine of 60 degrees. That makes them co-functions. These two angles that are complementary, 30 degrees and 60 degrees, their sine and cosine are the same. That will be true for any co-functions that we have. Meaning, tangent of 30 degrees is root 3 over 3. Cotangent is the co-function with tangent. So how could we use that? Well, if they're co-functions, then we take the angle that is complementary to 30 degrees, that's 60 degrees. And if tangent is my base function, my co-function is cotangent. Cotangent of 60 degrees has to be the same as tangent of 30 degrees, root 3 over 3. I know that is a little bit bizarre. It is a mathematical property, and your book mentions it, so I did bring it up. As far as its usefulness, you can use it a lot in math, in proving things out, and in verifying things, which we'll do later in the semester. Ultimately, given that you have calculators, if you're looking for the cotangent of 60, you don't necessarily need to use the cofunction property. You can just put it in your calculator and get an answer that way. Or draw an angle and find a reference angle and do things that way. So I'm aware there are alternative ways to find these. This is just a useful shortcut that you can use if you want to. And like I said, it is useful mathematically, even though for the most part we may not use it much in this class. As far as it goes, there is one more property that your book mentions in section 4.2 that I wanted to go over for these trig functions. I will mention it because I'm assuming you're reading your book, and so you'll see it in 4.2, but it won't actually make sense until we get to graphing, which we're going to do next, which is in 4.4. So for right now, I'm just going to mention it so you don't get confused when you see it in your book, and then we'll expand on it in a later video, in a later section, probably next week. And if all of you remember 171, we had functions that were even and odd. And they had certain properties. If you don't remember the actual formula, even functions, f of x equals f of negative x. For odd functions, f of negative x equals negative f of x. If you remember again from 171, even functions where this holds, that's the same as saying symmetric with respect to the y-axis. Odd functions are symmetric with respect to the origin. And as far as it goes, again, until we get to the graphing, this might be a little bit hard to understand, but as far as odd functions go, sine is an odd function. Which means when we get to graphing, it should be symmetric with the origin. Cosine is an even function. Which means cosine will be symmetric with the y-axis. We will see that in greater detail when we graph them. I mention it now because your book does. And again, as far as usefulness goes, in terms of math and verification, essentially one way we can use it, if I wanted to say, find sine of negative 30 degrees, I could draw the unit circle, draw my triangle, find my reference angle, do all of that. Or, since sine is an odd function, sine of negative 30 degrees equals negative sine of 30 degrees. And sine of 30 degrees, I know, that's just 1/2. So sine of negative 30 degrees is negative 1/2, and I'm done. And again, I'm aware, if you memorize the unit circle, there are alternative ways to solve this. This is just one mathematical property we can use that can be beneficial in problem solving and in verification of different things. And we'll see it in greater detail when we get to the graphing. That's essentially all of the properties we need for sine and cosine, and now for all 6 trig functions. There is one more topic I want to go over on another video I'm going to make, how we can expand on this idea of a unit circle to the entire real plane and use our trig functions to do it. And then from there, we're going to go into graphing.